With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hello everyone, let's start the question. The question says that at what positions the neutral points will lie for a bar magnet when magnetic axis of the magnet is lying in the magnetic meridian with north pole of the magnet pointing north, south pole of the magnet pointing north. So first north pole of the magnet is pointing north, second the south pole of the magnet is pointing north. Now let's just have an introduction about this neutral points. So basically what is neutral points? Neutral points are those points at which whenever there is a magnetic material placed, it is not going to experience any force. That means net force acting at that point on a given body will be equal to 0. Now why will it be equal to 0? Because there will be some equal and opposite forces acting on it. So the two forces which will be acting at a point in a given plane at neutral points is that the Earth's magnetic field, the intensity of Earth's magnetic field, and the field produced by magnet. So Earth's magnetic field, which is represented by BH, and field produced by magnet if it is represented by B. So whenever B is equal to BH, then we obtain neutral points. Now let's have some visualization of Earth's magnetic field. So if at all I am talking about Earth's magnetic fields, we know that Earth is close to spherical in shape. So let's consider this is the Earth. So there are 2 points through which the axis passes through. This is nothing but geographical North Pole and this is nothing but geographical South Pole. And the Earth also has another pole because of its magnetic field, and that poles are called as magnetic poles. And these magnetic poles are not exactly at the geographic North Pole and the geographic South Pole. Instead, they are at a different point. And these points, let's say, lie in a given plane in such a way that near the geographic North Pole, there will be magnetic South Pole, and near the geographic South Pole, there is magnetic North Pole. Now, how do we get to know this? Just by suspending a compass needle in whichever direction the compass needle deflects, the north side of the compass needle deflects, that will be the magnetic South Pole. So if I am producing or suspending a freely suspended compass needle, the compass needle's north will be towards magnetic South Pole. Why? That's because we know that opposite poles, unlike poles, attract each other. So therefore this has to be our magnetic South Pole. So the line or the axis which passes through our magnetic poles is called as magnetic axis. The line which passes through the geographic North Pole is called as our geographic axis. That's the axis about which our Earth is going to rotate. Now the question says that. What does the question say? We are placing our bar magnet in such a way that North Pole of the magnet is pointing the north. So when they say pointing the north, they mean to say geographical north. So as they mean to say geographical north, so in the first case, so the bar magnet is facing the geographical north, the North Pole. So let's say this is the bar magnet, this is north, this is south. So we know that the field due to the bar magnet will originate from the North Pole and terminate on the South Pole outside, whereas it originates on the South Pole and terminates on the North Pole inside. But if at all I am looking at the external field is in the opposite direction. It is from magnetic North Pole to the magnetic South Pole. Therefore, the external field, which is nothing but our magnetic field intensity due to our Earth's magnetic field, will be like this. So this is the Earth's magnetic field direction. We are not worrying about the magnetic field direction of our magnet. Now we are going to discuss about what would happen whenever Earth's magnetic field is interacting with the magnet's magnetic field. So magnet's magnetic field, let's try to visualize that also. It will originate on north, terminate on south. So if I am looking at both the fields, we know that they are opposite to each other. As they are opposite to each other, so at some point along the axis, they are going to cut out each other or balance out each other. And that along the axis, wherever they are going to balance out each other, so if I am showing it here, so these are the two positions, let's say, at which the two magnetic fields are balancing out each other. if I'm imagining a line passing through it, this will be nothing but the axial positions. So we are going to get the neutral points at the axial positions. So for the case 1, neutral points are at axial position. That happens because here they are balancing out each other. As I am moving further, they deflect from each other because it's almost tending towards the North Pole. Therefore, it's going to be a curve such that the external field line, that is Earth's magnetic field lines, will deflect from the bar magnet. So that way, we see that the cancelling happens along the axial point. Now, what happens in the second case? Now, what they say in the second case? In the second case, they are telling that the south pole of magnet is pointing the north. So, in the case 2, again let's visualize it with a diagram. So, draw a bar magnet. South pole is now towards the geographic north, but you know that your magnetic field due to your Earth remains the same, its direction is the same. But now if at all I am looking at the direction of the magnetic field of our magnet, it is from north to south. It's in this direction, and Earth's magnetic field is also in the same direction. Correct? So as they are in the same direction, so it's going like this. So this is tending towards the North Pole. So therefore there is a possibility that this field line is getting attracted towards the South Pole. Therefore, the field lines which are very close to the given magnet will get curved towards the magnet. So it looks something like this here. So here also they get curved. So this is where they are going to get curved, and again all the field lines are going to be curved. Why? Because opposite directions, so there is a tendency of attraction. So whenever attractive forces are there, the field lines will tend to compress at a point. So this is how we are going to get. Therefore here, since the field lines are all in the same direction, we are going to get neutral points along the equatorial position. One neutral point will be above, another neutral point is going to be below, because this north and the below north, the repulsive forces tend to cancel out each other below, and this south and the above south, repulsive forces, they tend to cancel out on the given equatorial line. So in the first case, neutral points are at the axial position. In the second case, neutral points are obtained at equatorial position. So this is all about the production of your neutral points. Thank you.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.